And so it is. Welcome to Auth Part 1. So, by the end of this lesson, you should be able to create new users in Rails and explain how hashing works. So, creating new users in Rails. 90% of this is stuff that we should be able to do in our sleep. It's just creating a resource. That's it. Just like dogs or bagels or anything else, you're just creating a model, a migration, and a controller, and a route. The other part of this, the other 10%, is a gem that comes like configured in your gem file already. You just got to uncomment it, and it will allow you to add a hashed password to that user's database record. That's it. It ends up being like one line of code, and ta-da, you can hash passwords. But what is hashing a password? Why would you hash a password? Who gives a shit? Why would you not want to store a user's password directly in the database? Riddle me this.
Because if someone breaks into your database, they just have it in plain text.
Yep. Someone gets into your database, they got all the users' passwords. Probably have all kinds of other problems, but that's certainly chief among them. Because like, hey, they could even pretend to be those users without letting us know that they broke in. Uh-oh. They're reusing those passwords on other services. Yoicks. But if I don't have their password, how can I tell whether or not they type the right password when they log in? How does that work?
Some form of encryption?
Kind of. Related. It's not encryption, but it's real close. Actually, let's stick with that for a sec. So encryption is, I make a secret message. I use a thing called a cipher to scramble it. And then if you use the same cipher, you can unscramble it and get back my message. I also don't want to do that with passwords. Why?
Someone could find your cipher.
Mm-hmm. You can break into my database and get my cipher. Now we're in the same position we were in the first one. Uh-oh. So what else could we do? It's cool if you don't know like the vocab for it, like get creative.
Is it a token?
Not a token. We're going to use those in this series to prove that we have logged in, but not quite. You're on the right track though. How do I know that a password that a user gives me is the same one they originally gave me?
You you associate the values in a hash, but I don't really understand how that works.
Hashing is the answer to this. Can anybody expand on that?
So you pass it through like a function that does something,
Yes.
and then you pass whatever you type in as your password through the same function, and you should get the same result.
Bravo, bravo, bravissimo. That's exactly what we want to do. So what we want to do is have, when you give me the password, I send it through, we'll call it a hashing function. And a hashing function, wait for it, hashes strings. So it poops out a hash. And then later, down the road, if we give it the same password, we end up with same hash. So we end up comparing hashes. Okay, but I just told you about why we shouldn't use encryption for this. Can anybody tell me how a hash is different than something that's encrypted?
Is it because all of the processing is just taking place on the server through that function?
That's a super good guess, but no. Let me show you what Kyle's super shitty hashing algorithm looks like. Kyle's super shitty hashing algorithm is letter substitution. So I say C, A, T. I do 3, 1. I always forget what T is. 17, I think. Okay, and then I add these together, and that gives me 21. I have 2 digits, so I add those together, and I get 3. So I could say that the hash of cat using Kyle's shitty hashing algorithm is 3. How can I reverse that and take 3 and get cat?
Can't.
You can't. That's the point. It goes one direction. Because other things that generate that same hash, C, A, all of those will have the same hash. If you have a hash, you can't decode it to get what the original value was. Now, the trade-off with that is that multiple things can have the same hash. When we're not using Kyle's shitty hashing algorithm, we're talking about billions and billions and trillions and zillions of options. And so for our purposes of this password thing, my password is going to have a hash. Lots of other passwords have the same hash. What we're relying on is how astro-fucking-nomically unlikely it is that you can intentionally give me a password that generates the same hash. If you can do that on purpose, it's called a hash collision. And that's a massive big deal in the security community. If you can do it with one value, they pretty much retire an algorithm if you can intentionally cause a hash collision with anything. In my career, that's happened once. Ask me some more questions about hashing.
So
Does it always use numbers?
Hmm?
Does it always use numbers?
No. Well, in the sense that everything in a computer is numbers. But it's actually hexadecimal. So each character can have 16 different values. That's 0 through 9, A through F. Yeah.
Do all the web frameworks kind of use the same hashing algorithm, or are there a bunch of different ones? Or
Great question. There is a bunch of different ones. The one that we're going to use is called bcrypt. Bcrypt is really common. And so what we're always trading off against with hashing algorithms is when you're not using Kyle's shitty algorithm, it's actually a lot of steps to generate that hash, which is more CPU time. And so you're always trying to have something that is secure, can't be reversed, can't be collided, but also doesn't take a long time to do. And so those are the two things that people who make hashing algorithms are always trading off against. By the way, this is part of like what you would do with like a career in math. It's like design these algorithms. Bcrypt is a super popular one right now. But there are others. One other cool thing about hashes, check this out. I always thought this was kind of neat. So we can use them for passwords. So we don't actually store the password. We store something that the password hashes into. That's not the only use of hashes. Hashes get used all over the place. So for example, if I go to some repo and I do git log, hey, you see those things for each of your git commits? Those are hashes. So you take all the changes from whatever commit and you hash those and you take the resulting hash, and now you have a pretty damn likely to be unique value representing that commit. So they get used for universal IDs a lot also. Now keep in mind, we're dealing with statistics on this. We could accidentally have a hash collision. That happens all the time. So we're dealing with just extreme unlikelihoods that a collision happens. That ends up being an okay trade-off.
What happens when you do have a collision?
You get really weird-ass behavior. So for example, if you had two commits in the same repo that had the same hash, you'd have problems. Now, what you probably have to do is just dig in there, change one of them a little bit. It wouldn't be an easy process, but it'd sure be a fucking rare one. In the case of the passwords, somebody accidentally enters in some string and they put the wrong username in, but it accidentally logs them in anyway because the hash is the same. Because like, keep in mind, you might type in Bixby as your password, but it's not like Bixby1 is like another thing that's going to match. They design these algorithms so that a little change in the source string results in a huge change in the hash. That's one of the criteria you like evaluate a hashing algorithm by, is how much difference there is between those. So another thing that would have the same hash as Bixby is just as likely to like be this string. Other questions about hashing?
So is it just like I don't know, like a hash table, and if it hits something, that a key that exists in the table, then it gives you a thumbs up? Is there anything else that's stored in the table, or is it just those keys?
So using a hash like how we use it in Ruby, those also use hashing functions. They use it in a different way though. So that'll be a third way. We got this password way, we have unique identifiers, and then we have hash tables, which are like hashes in Ruby. JavaScript objects are technically hashes. That has to do with how we, actually it's really fucking way down in the weeds. It has to do with if we want to store these different things that are on a hash wherever we want on our in our memory in the computer, the hash helps you figure out where the location of that is. Yeah, that also uses hashing functions, not the same thing. This is more like I put this string in, I get this other string out, and that's what I put in the database. And then when you log in, I hash that, I pull the value out of the database, and I check to see if they're the same thing. More questions about hashes? Cool. So let's talk about creating new users in Rails. So these are the steps that I'm going to follow. I'm going to code this. I want you to watch. Don't code along with me. You'll get a chance in a sec. Just watch. So I'm going to go make a new repo. And I am going to, let's see, Auth part 1. All right, so I am going to Rails new API, and I'll call this backend. So it scaffolds out this app for me. Step 0, I have to install bcrypt. So I'm going to go over to the gem file, and down on line 17, I have this commented out bcrypt gem. All you got to do is uncomment it. Bundle install. Oops. Bundle install. And we're good to go. That's step 0. Step 1, we're going to create a route to create a user. Resources, users, only, create. Step 1 done. Step 2, we're going to create a controller to create a user. All right. It is so. So we go over to that user's controller, and nothing special here. We call it create. We say a user is user.create. We're going to take in a username and a password. But this is just a regular Rails model. We can put whatever else we want on here. We can have real name, age, whatever we want. It's not just limited to those. And then we're going to render the response. Cool. Step 2 done. Really that easy. Okay, this is where we do something different. So we're going to create a user model with a secure password. See, here's how this works. Rails G model user. There are 2 things that we do slightly different on this. On the migration that we made, we're going to take in the string for username. And then we're going to take in the password as, wait for it, password digest. It's called password on your front end, in Postman, in your controller. Once it makes it to the model and starts going on its way to the database, it gets turned into password digest. That's the hash of the password. That's the thing we put in the database, so that word is different. The other thing that we do is we go to the model for user, and it's has underscore secure underscore password. That's a macro, just like adder reader or has to, has many, belongs to, any of those kinds of things. It's just like that. What that does is whenever in our controller we try to create something with a password, it translates that to password digest, the key, and takes the value and hashes it. That's all that does. And then stores that in the database. That's it. That's step one, or that's part one of this series, is all those things. So let's see it in action. If I Rails S this, okay, it's served on port 3000. I wait forever for Postman to load. I don't know what happened with Postman, man. It was like, it used to be wicked fast. It gets slower every year. Change that to 3000. Change this to a post for the body. Username is Kyle. Password is Kyle. It's lowercase. Cool. So I send that over. And wait for it. You get a 500 because I didn't run the migration. Rails DB migrate. Let's try that again. No route matches post whatever. Yeah, that's because I have to send it to the right actual thing. Post to users. Hey, so there's my username and there's my hashed password. Kyle hashed into this. Ask me some questions.
So what happens if you don't have that has secure password in the user class?
It's going to go, you don't have a field in your database named password. Or, yeah, I have a password digest. So then if you pass in password digest instead, then it'll just store your plain text password. Another way to visualize that. In Postman, password is Kyle. So then it ends up going to your controller action. Still password Kyle. And then goes to your model where it becomes password digest and becomes whatever the hash is. And then it goes to your database where it's password digest and the hash.
So is that has secure password, whatever you had in the user, is that what's creating the password, like the hashed password digest?
Yeah, has secure password changes the name of the key from password to password digest and hashes whatever the string is.
That's what's doing the work?
Yes. Has secure password just does all of that in one beautiful line of code. If you ever watch one of the auth videos for Node, it's the exact same steps as everything we do in Rails. We just have to do it all by hand. So you need to like actually make the hash yourself. But otherwise, same idea. Rails wants to be friendly, so it wraps it all up in one line of code.
So if you had another user that you created with the same password, Kyle, it would be
Yeah.
the same hash?
Ooh, good question. Let's see. So take a look at this. It ends in nay, has this ICR in there. So let's say I change the username to Elise.
You could post it real fast in chat.
Oh, look at that. Not even kind of the same. What about Duncan? Still a super different hash. What the fuck?
Is it building this hash off of also like the username so that they can't be the same?
No, it's only using the input string. That's a good guess.
Is it at the time it's created?
Also a very good guess. No, not quite. This is like a miracle. This is so brilliant how they did this. Take a look at the beginning of this hash. So I'm going to do another one. Some of it stays the same. See that part?
Does it relate to the created at in the database?
Nope. All it is, we could take out everything else. No ID, no username, no timestamps, and it would still work the same way. All it needs is the string. Doesn't need to know anything else. See how those first couple characters stay the same no matter how often I do this? There's other things in this hash that are part of the input information. For example, this first one, 2A, that's the version of the algorithm. This is the second edition revision A of the bcrypt hashing algorithm. This 12, that's the cost. I mentioned that like we're always doing the trade-off between how secure is the hash and how quick is it to calculate. Cost is a way to control that. So 12 is a good default. If bcrypt is still around in 5 years, that's probably going to go up because it has to do with how fast crackers' computers are, how fast they can generate these hashes. So you make it more secure if you up that cost, but then your login spinner takes longer for you to log in. So that one just inches up over time. And here's the craziest part about this. The first few characters of this, I think it's like 5 or 6 characters, aren't the hash. They're an extra little bit of information called the salt. By the way, hashing, salting, these aren't math terms, they're breakfast terms. So like you're making hash browns on a grill, and then you make some more potatoes, you throw them in there, and you start mixing them in. And before too long, you can't tell which potatoes, which part of the hash browns came from anymore. It's all mixed together. That's why they're called hashes. So the salt, what this is I pass in Kyle. It takes these first 5 randomly generated characters, adds them to the end of Kyle, and then hashes that. And the result is this. And then all of those things get stored in the database. So when I try to log in again with Kyle, it's going to go, okay, this is the version of the algorithm I'm using. I'm going to add these first 5 characters to the end of Kyle and then hash that using this version of the algorithm. And the result should be the rest of this. It's pretty fucking cool, right?
I'm a bit confused. Are we talking about a hash like in Ruby then, or something totally different?
No, we're talking about the thing that hashes in Ruby are based on. This is more fundamental than that. Don't try to like make the connection to a Ruby hash and this though right away. It's complicated and not useful right now. A hash is just something that scrambles up one string into another string. Or a hashing function is something that scrambles one string into another string.
Okay.
It hashes it. But the way we prevent my password is Kyle, and Adrian's password is Kyle, and Logan's password is Kyle, and we all have the same hash in the database. What would the problem with that be? Who cares?
Somebody could figure out the hash algorithm based on like if everybody had the same hash for Kyle.
They couldn't figure out the algorithm. The algorithm's public. Everybody knows the algorithm. They could figure out my password because turns out there are like more commonly and less commonly used passwords out there. So if you see the exact same hash show up 20 times, and then another one show up 18 times, another one show up 15 times, and another one show up 12 times, and this one shows up 8 times, we got a bunch in there. So we start getting a distribution of these hashes that kind of looks like that. Guess what? I'll bet if you compare that to a list of the most commonly used passwords, I'll bet you can make a pretty fucking good guess at what these original passwords were.
Ooh.
That's called a frequency attack. Frequency as in like statistical distributions. You can make a statistical guess at what the original passwords were because all the hashes are the same. You throw the salts in there, now you can't do that anymore because those characters are just randomly generated.
So when you're trying to log in, how does that process work?
So we're going to talk about that more tomorrow. That's the theme for number 2. But as a preview, you're going to give your password. Your controller action is going to go, cool, is this the same as the password? And we get another cool thing with Rails for free called Authenticate. That's going to do the process of using the right version of the algorithm and adding the salt to the password that you gave it and hashing that and then comparing it with the thing in the database. It does all of that for you. And then just gives a thumbs up or a thumbs down if they match. If it's
So it uses like the salt and the version to make sure they're comparing the same thing?
Exactly. All that gets automated for you. You don't have to like split off the first 6 characters, like anything like that. It's all automated.
I assume that's not the case with most backend softwares.
No, that part actually is. So even in Node, the Node bcrypt module also has an authenticate method that does all of those steps for you. Has secure password, that's pretty unique to Rails. But the actual comparison process, comparing the hash in your database to the one that you did, that one isn't. That's pretty standard. Other questions so far? Cool. I want you to do this now. I want you to make a new Rails app. I want you to install bcrypt, create a route to create a user, create a controller action to create a user, and then see if you can remember, has secure password in the model and password digest in the migration. It's the only 2 differences. They look like that in the model,
I'll secure password.
that in the migration.
Password digest.
Let's take a few minutes and give it a shot. Go. You'll know you did it right if you can post to the database or post to your API like this and get something like that back.
Huh? Okay, why is this not? Oh, because I need to. Oh, is test? Test must be one of those reserved words. Okay. Mm, 17 jump file. It's not capital decrypt, it's lowercase decrypt. And we need to go and get cores.
All right. So let me get a quick fist to 5 on this. Fist is what we're supposed to be doing. 5 is I got a hash coming back, baby. Throw it up, keep it up. Thank you. Thank you. Thank you. Okay, cool. So I'm going to walk through this one more time, and then we're going to hit some questions. So wipe, delete, go away. I'm going to Rails new dash API backend 2. And then I'm going to step 0. Install bcrypt. Bundle install. It's done. So then I go over to the router. I make sure that I can route to this. Done. I'm going to make a controller. I'm going to make a create method. I'll take in the username, take in the password. It's still password here. It hasn't gotten turned into password digest yet. But param's password is what came in from Postman. Password is what we're sending to the model. Model's going to turn it into password digest. This is the problem 99% of the time students working through this, is getting those mixed up. Cool. Controller is render JSON. Ah, come on, man. Monday for everyone. Cool. So controller's done. That's it. Now I'm going to Rails G model user. Go into that model. Has secure password. That's what goes in the model. Over in the migration, t.string username, t.string password digest. That's what the model turned it into. And that's it. We run the migration. We serve it up. We fire off a request. And there we go. Questions? Cool. Do it again. This is something we got to get fast at because we're going to do a lot the next 2 days also. So I want you to follow the steps. Let's take another 5 minutes. Go. Start over again. Whole new one. Even if it worked, didn't work last time, I don't care. New one.
Did you get a ticket for this?
No.
Do you have an account?
Nope.
Okay, I'll do that. I called them. They're like, you must have a ticket number.
Could I see what you did with your routes?
Yes. Thirty seconds. Cool. So same question. Fist to 5. Fist is I have no idea what we're doing. 5 is I got a hash coming back. Throw them up, keep them up. Beautiful, beautiful, beautiful. Thank you, thank you, thank you, thank you, thank you. How you doing, Justin? Oop, fist to 5.
I'm having trouble having it show up in Postman, but I think I did everything right, but I guess I didn't.
All right, all right. Cool. Thanks, Will. All right. So
I keep getting a 500 error telling me that I'm giving the wrong number of arguments, but
ooh.
it's not the wrong number of arguments.
Why don't you screen share and let's see if we can debug with you. All right, in your user's controller, you're given the wrong number of arguments. So your create method, user.create. Anybody see it? It's a subtle one.
The at symbols?
Not the at symbols. Well, yes, the at symbols, but that's not the only thing.
Colons after the key name?
Yeah, colons not equal signs. Cool. Anything else?
So I have a question about what it actually sends over through the server, because when you look at what it sends over, it says like password filtered. So like, how does it know to do that?
Oh, in your server logs?
That's right.
It's because Rails knows that that's a password because you use the has secure password thing, and like has the good fortitude to not log the password that you sent over. Because, and this is like a pretty common attack vector, no need to crack into the server or like undo the hashes or anything like that if some dope is console logging every fucking string that comes through the server, and that gets put in a file somewhere and you can just steal that file.
like where does that change take place? Like as soon as it hits the route, or
So it's that's going to happen. That's a good question. If it happens by the time it gets to the model, which it very well might, because the very first thing that we do in that controller is like user.create. Well, that's a method on the model. And so your model has an idea of what is and isn't a password. It's also, and this would be a very Railsy thing to do also. Rails might also just check for the word password and not show any value if the key is password. That would be a very Railsy way to do that.
so then to like piggyback off of that, is that a Rails specific thing, or does that happen with any framework? Like when you send that back?
That's definitely a Railsy kind of thing, is filtering passwords. Everybody else would go, well, you could add in your own plugin if you wanted to do that, but the convention over configuration approach with Rails is like, how about we default to a good choice? Other questions? Cool. To give you a roadmap of where we're going, tomorrow we're going to talk about logging in. How do you use this username and password to log in? And then the third part of this is, all right, I'm logged in. How do I make it so that some part of my apps can only be seen by logged in users and other parts can be seen by everybody? Very first thing I'm going to ask you to do tomorrow, though, is all the things we just did. You should be able to create a user like that. Last call. Going twice. Lunch is ready? You want to say hi to my students? Oh, look at this guy. Can you say hi? Oh, now you're getting shy. Okay. Thank you all very much.